The Neubauer counting chamber allows quick and simple determination of the number of cells in a solution. Besides more modern, automated cell counting devices, this rather traditional way of counting cells by hand is still a widely used technique to estimate the cell count. A Neubauer slide has 2 spots for the application of the sample solution. Each of those spots measures 3 × 3 mm and consists of 9 squares. A square is divided into 16 smaller boxes. One of the 9 big squares, which will later be used for counting cells inside, has a size of 1 × 1 mm, resulting in a surface area of 1 square millimeter. Since the 3-dimensional solution is applied onto the slide, the height is also an important parameter to calculate the volume of the sample. In a Neubauer counting chamber, the distance between slide and the cover slip is 0.1 mm. In total, that means one of those 9 squares contains a volume of 0.1 microliter. Here is one example to showcase how the Neubauer counting chamber is used for cell counting by hand. To determine how many cells per milliliter grow inside the cell culture flask, the cells are first detached from the cell culture flask. The next step is to dilute the cells. This is optional, but may help especially when working with a high number of cells. 1 milliliter of the cell suspension is, for example, diluted in 9 milliliter of water or medium, making a total volume of 10 ml. This 1:10 dilution can also be described as a dilution factor of 10, which will be required later in the calculation step. The next step is the application of the sample onto the Neubauer counting chamber. Usually, the applied volume is 10 microliter. Under the microscope, the counting chamber looks like this. The red spots are cells, and the 5 yellow squares serve as the counting area. Starting with the first square, all cells inside are counted. There is one cell touching the outer line of the square. You may wonder whether it belongs to the square or to the one below. The rule to resolve this issue is that cells which touch the lower or the right boundary are counted, but cells which will touch the upper or the left boundary will not be counted. After the counting is done, for all highlighted squares, the average number of cells per square can be calculated. In this case, this is 10 cells per square, which equals 10 cells in 0.1 microliter. But how many cells do we have per milliliter? Since 1 ml is 10,000 times as much as 0.1 microliter, we have to take the multiplier of 10 to the power of 4. 10 cells times 10 to the power of 4 times the dilution factor, which was 10 in our case, makes a total number of 1 million cells per milliliter. And to make sure that this channel also reaches 1 million subscribers one day, be one of them starting from today. Hit the subscribe button, it is for free. If you have further questions, let us discuss those in the comments. Make sure to like the video and see you soon in the next one.